Let's see. It's just me. Hi, how's it going? All right, just making sure my audio works. Okay. Floating head delicate. Oh shit, let's not leave it like that. Okay. Yeah, my eyeball. Oh boy. Yes, I'm recording me checking my hair. Let me see if that looks all right. Or Lanja.
Good morning. Can you hear me?
Yes.
Oh, okay. This is cool. It's my first time speaking in a Zoom meeting.
Yeah, this whole thing is it takes a little getting used to for sure. Let's see.
Hey, at least we have this.
Yeah, exactly. Let me see. I'm going to check to make sure there's a bit of a glare. Worse. That's not overly bad. I just can't. Anyway, that looks not too bad, maybe.
Yeah, I can. The glare went away actually when you
Yes.
pat that down.
It's just a balance between making the glare go away and then making it too dark. It's crazy. Let's see. I think you had emailed me about something. Did we figure something out or something?
For the chapter 3 homework?
Oh yeah, good. So you sent that to me. I got it.
Yeah, I sent that to you via email because it wasn't on Canvas.
Yeah, I got you. I got it.
Before others join, I had a couple questions actually due to Canvas. So you said last class that if there is no due date, because for example, chapter 6 and chapter 7 have no due date yet.
Not yet. I mean, they will. I just got to figure them out.
Okay. So you'll tell us by today or this week somehow?
Yeah, just pay attention to Canvas.
Sounds good.
They'll probably be due next week. Hopefully I'll update that today.
Okay. And
Yep.
as for the corrections, I've sent you quiz correction number 1. And then today, by the end of today, I should have the double quiz in there and test number 1.
Sweet. All right.
Hopefully.
Doing pretty good.
Thank you.
Yeah. I just graded the quizzes that I gave my Math 90 class yesterday on Canvas.
Okay.
And it went pretty well. I kind of like grading it in Canvas because I can type and draw stuff. So that's nice. Let me see. All right, good. Morning, guys. Everybody who just joined in. Oh, okay. Connecting to audio. Okay. Let me see. I don't know. It still seems kind of dark in here. What can I do? can I do? Oh, the glare's back. Oh, scheisse. Oh, man. There's just no good way to do this. Well, what can I do? Okay. If anybody has a question, just feel free to, you can chat it at me. You can say it to me before everybody gets here. All right. More and more people. So as you, let's see, got a couple more people. As you guys log in, you can ask questions or you can just hang out till 9 o'clock when we start officially. Hello.
Pero, sí me dio.
All right, I muted everybody. If you have a question, unmute yourself and ask away. We got about, what, 7 more minutes? This is so weird. It's my happy place. Malachi's here, yay. Sorry. So again, as people come in, if you have questions, feel free to type it or say it. Just if you have questions, we got about 6 more minutes till things get started officially. Stop. I'll stop. Maybe I'll stop. Interesting. I gotta check that out. Oh. Oh, it's what you do to me. Oh yeah. I think it's. Oh, I'm gonna say this again later, but the quiz is being it's gonna go live on Canvas the minute that this lecture's over. We got 4 more minutes of awkward staring at each other. It's timed in the sense that it's due at midnight. Mm. It's what you do to me. Oh, it's what you do to me. Good morning. Around 1 p.m. So again, I'm going to say this again later, but the quiz will go live on Canvas right after this lecture. Oh, here we go. Let me let a few more people in, and then I'll say it again. The quiz will go live on Canvas right after lecture, and it will be due by midnight, by 11:59 p.m. Where's my hand? Oh my God. Yep, you could do that. So again, I'll say this again later, but if you have no printer or your printer's out of ink, you can just do the quiz on another sheet of paper, scan that and send it, and upload it to Canvas. I'll say all that again in a bit. I don't know, Lonja. Primarily, if something's late, it depends on how late it is and how much you've turned in late. To be honest, in the perfect world, I wouldn't make homework due. I wouldn't make anything due. You just do it because you want to learn. But due dates are necessary so that people do things by the time that it will most help them. So, I mean, it's kind of, you will lose points if stuff are late. But if they're not very late and if there's not a lot of stuff that's late, maybe you won't lose anything. It depends. But again, I've got to do things to trick people into doing what's best for them. That's a huge part of being a teacher. If you ever think about being a teacher, that is a huge part of the job. Oh, okay, sure. Let me let some more people in. Kind of like when I put the doorbell on. Come in. Let me see. Not too bad. Let me make sure. It looks like everybody's got their actual name as their handle. That's good. Okay. I finally figured out a better way to take roll. I could get a participant list from Zoom. So as long as your names are who you are, then I can get that list. Let's see. Oh, it's about time. Yeah. All right. Let me see. How many people do I have right now? I don't even know. 25 now. Not horrible. Oop, there's another one. Let me just open the door. Oh, there we go. Door's open. No, you don't. So everybody, don't worry about saying here or anything. I've found the place on Zoom where I can download participant lists for every meeting. So I have a direct access to attendance. It also has, interestingly enough, what do you call it? I forget what it's called, like a participation score. It could tell if you're actually in front of the camera, which is neat, even if you have your video turned off. Because I'm always curious, if somebody turns the video off, maybe they go back to bed. I don't know. I see their name, and I'm like, oh, good, they're here. But it's college. It's up to you. Okay, guys. So let me say this. Several people asking questions about the quiz, which makes sense. The quiz is chapter 5 and 6. It's gonna be live on Canvas right after this lecture. It'll be due by 11:59 tonight. If you send me emails at 11:30 p.m., I'm gonna be dead asleep. So if you can't download the quiz, don't. Just do the work on another sheet of paper, scan that paper, send it to me. I mean, I know what the questions are. I don't need that. If you can download the quiz, do the work there and send it in. That's great. Send your quiz back over Canvas, not in my email. My God, I don't want to have to go back and forth. Anything else about the quiz today? Any other questions? No. Okay. All right. So if you have a question, there's that raise your hand option we had talked about before. You could just type a question into chat. I don't know if there's too much going on in chat, I'll say whoa, because I don't want to try to keep up with that too much. Okay, let me turn off my happy place. Bye, happy place. Oh, okay. Oh, let's see. Okay. So what I want to do today, I want to first focus on if anybody has any questions, especially related to the quiz today. But did everybody get the review sheet? Did anybody not get the review sheet? Does anybody not realize that the video solutions for the review sheet is up on YouTube? And of course, the minute I say that, if you say no, that kind of is silly because now you know. So there's a review sheet up on Canvas. It's basically what practice test 2 would have been. And the solutions are up on the YouTubes, on the internets. I am not going to continuously put in Canvas a note when I put something up on YouTube. I'm just not going to do it. I can't remember if I said this last time. No. So you do not need to turn the review sheet the same way that you never needed to turn in the practice test. I've got the solutions up on YouTube. Why do I want to see it? What was I saying? Oh, I'm not a YouTuber. I don't monetize my videos. I don't give a shit how many subscribers I've got. But if I were you, I would subscribe so that I know when something goes up. It might be for my Math 90 class, but oh well. When I put a 160 related thing, if I were you, I'd want to know the minute it goes up. I'm not going to try to keep track of it in Canvas. I'm sorry. So everybody, any questions over anything I've just said? Oh, somebody's got more. Somebody doesn't like something. Evan, you don't like something. What's up? You okay out there? Evan just says, I hate all this shit. I can relate to that. I understand. I guess. Oh, here we go. Oh, okay. Sorry, Evan. I didn't mean to call you out. Okay. You clicked the wrong thing. All right. No worries. I can totally understand that. Okay. So as people log in, let me say this again. The quiz will be on Canvas after the lecture is over. Go there, download it, don't download it, but either way, do the work, scan it, send it to me by 11:59 p.m. tonight. If it's late, then you're going to lose some points. You guys are, anyway, some people were up at midnight last night emailing me. I'm not going to be awake. I can see when you turn it in, so I'm going to grade it, later. Okay, so any questions about that? The quiz that's happening? Did I mention last time? I will put this in Canvas. Let me put a note here. There will be another quiz. Oh joy! I don't know what I did with my pen. Oh, there it is. All right. There will be another quiz on Tuesday. Did I say this last time? I'll say it now. It'll be on chapter 4 and chapter 7. That's weird. This quiz today is 5 and 6. 5 and 6. The quiz on Tuesday will be 4 and 7. 4 and 7. And together they make what test 2 would have been. Okay. Any questions about that? I'll put a notice up in Canvas about Tuesday's quiz. All right. If you're just joining us, you might want to see this video after I put it up on YouTube so you can catch up on what you missed. I'm not going to say it for the 8th time. All right. Anything else? Anything else about the quiz today, or any technical issues or anything? Everybody's okay for the most part? I don't need anybody to give me comments about, you know, I hate this. Why are we online? No, we just are. It's too bad. Okay. So now I want to focus on, anybody have questions from the review sheet, from homework, primarily 5 and 6, because that's the quiz today. But if you got anything from 4, 5, 6, 7, we can do those. Anybody, anything, homework, review sheet. If you're like, what the shit is this review sheet he's talking about? You can ask me that. Let's see. Chapter 5. Oh, what would have really been smart is if I would have pulled the book up before I was asking. But, you know. Da, da, da. So let's see. Section 5.1, number 9. So that's going to be from the, what do you call it? Uniform distribution. Come on. Come on. I reset all my Wi-Fi stuff. Yesterday was neat because my Wi-Fi was going in and out. Should be good. Let's see. There you go. I'm catching up to you guys. So 5.1, number 9. Boop. If you make the sound, it doesn't work. Okay. Here we go. Here we go. So number 9 says, a continuous probability function is restricted to the portion between x equals 0 and 7. So all they're saying is you have a uniform, it's not even uniform necessarily. It just says you have a continuous probability and the only x values it works for is 0 to 7. So what's the probability x is 10? While you guys think about that, just in case you notice, you know, I think I told you about my eyeball, right? So I had my visit to the doc yesterday. That was exciting, going to the hospital. Got my shot in my eye. Oh, shit. And this, I'm going to let this grow, and I'm going to call the result Cobeard 19. Good. Yeah, so the probability x is 10. If it goes from 0 to 7, the probability x is 10 is 0. For 2 reasons. It's outside 0 to 7, and it's x equals 10. No area. So it's 0 for 2 reasons. Okay. Let's see. The other question, chapter 7, question 64. That sounds familiar. Let's see. 64, and you say specifically part C. Oh, good. Okay, perfect. All right, so let me set this up. You guys got to let me know if the lighting's bad or anything. I can't do anything about it, but I just, I just want to know. Which pen is going to work today? Let's see. Here it is, Jeff. Suppose that a category of world-class runners, is that the one? 64? Yeah, okay. Here we go. Okay. Suppose that these runners run a marathon, an average of, oh God, that's not going to work, is it? Can you see that? You guys can see that, but it's kind of sucky. Give me a minute. I need to venture out into the world and buy some more markers. How's this one going to be? Ooh, look at that. Ooh, shit. Let's see. So this is 7-1. 7-1, right? Yes. 64. Let's see. The average time for these runners to run is 145 minutes. You guys can see that. with a standard deviation of 14. And let's see, consider 49. So then they take a sample of 49. So what should I change? I got really close there, I'm sorry. What should I change if I'm going to talk about sample means? I took a sample of 49 runners. Yeah, standard deviation, I like it. So what would the new standard deviation be for the sample means? I would take the old one divided by the square root of n. 14 divided by 7 is 2. Why am I doing all this work for you? I don't know. All right, I like it. Everybody with me so far? So this is number 64 on 7.1. Part C then says, so the question was specifically part C. Find the 80th percentile time for the average of the 49. This one's got quite a bit going for it. Take a minute and try to, what would that look like? Why can I draw this picture? Why can I draw it in that shape? What do I know this distribution is going to look like that? Yeah, the sample size is more than 30. Kick ass. So all the sample means will have that shape. Beautiful. Where's P80 going to be? Is it going to be down here or up there? Down here or up there? I like it. It's got to be up here so that it has 80% below it. That's what P80 means. It's the point that has 80% of the data below it. I like it. So here's what you got to do. You got to find the z-score that goes with that, the z-score that goes with this, and then you got to convert that back into a mean time. You got to convert that back into this. We do that with this formula. Normally it would be this. Oh shit, I'm getting down at the bottom. Normally it would be this, but I know I'm talking about sample means, so I got to use the standard deviation for sample means. We've done this kind of problem before, we just never did it after changing the standard deviation, but it's the same problem. I just have to use the right spread. Maybe? Maybe? No? Yeah? Anybody need more on that one? Are you guys okay? I don't want to do the whole problem for you because I got enough problems. Okay, nobody's saying they have any trouble. Then what? I missed a question. Let me see. Thank you. 7.3 is you were the one that said that earlier, right? 7.383. Okay. 83. Oh. So this is basically the same thing. This one gives you the mean, gives you the standard deviation. Then they take 16 gas stations. So you've got to do this with the standard deviation, right? I don't know. Let's see. If I would have just prepared. What was I doing this morning? I'm going to take this away. Bye. Okay. Number 83. That works better. Number 83 says the mean is 459. The standard deviation is 10 cents. Holy shit, 460 for a gallon. Let's see. And then they take 16 gas stations. And they ask you, what's the probability that the average for the 16 is more than 469? So, I mean, this is going to be one where, of course, before you do anything, you need to change your standard deviation. Then you draw the picture, you find a z-score, you look it up on the z-score chart, bam. Oh, let's see. That's a good question. Sometimes they're really bad about, here we go. Yeah, you're right. Yeah, this is a bad one. Oh, so, okay, I see now. This book, sometimes they don't say it's normal and you just have to assume it is. Sometimes they say, assume all these coming are normally distributed. The point of this problem actually is, this is one where the right answer is n big enough to draw it like this? Because they don't say it's normally distributed to begin with, and n is not bigger than 30. So I actually can't do this problem at all. So that's my fault. I'm sorry. But this book is a little bit, sometimes they don't say it's normally distributed and they just want you to assume it is. This problem, I think the point of this problem is, I don't know that it's normal and the sample size is not big enough. So every now and again they'll do that, but yeah, it's unknown because we don't know what the distribution looks like. I like it. So this one, so I'm not sure how to help you with that because that is one little quirk of this book. There's not a lot of the problems they do this on, but sometimes they don't say it's normal, but they want you to do the problem anyway. This is one where they don't say it's normal, the sample size isn't big enough, so therefore I can't do anything with it. Okay. So I apologize. I mean, it's a free book, so you know, I can handle mistakes a little bit better than I can for a book that it costs $200. Anything else, guys? I don't think I saw any other questions. Yeah, I don't see anything I missed. Okay. So not seeing anything else, we're going to get into new stuff. Let me see if that makes anybody ask something. No, okay. All right. By the way, I'm not going to check everybody's name here, but make sure that your username, that your name that shows up on here is your actual name, because I've discovered a way I can get a participant list. So that's going to be my attendance list. So in some classes, I have people logging in and their name is iPhone. And I'm like, well, the iPhone's going to pass this class because it's showing up all the time. So you better make it your actual name. I think everybody I saw had their actual name. Okay, so there's nothing else. We're going to get into new stuff. Here we go. All right, still not seeing anything else. Here we go. Let me see if you're going to work today. So what we're about to get into is chapter 8. And okay. We're going to end up using a formula that we know really, really well, or we should. We should all know this formula. In fact, I just used a version of it a minute ago. But in statistics, what normally happens is I don't know what the actual mean is, right? If I discover, if I find in living in a bay somewhere, a group of dolphins, do I know what that population of dolphins lifespan is? No, I don't know what their average lifespan is. I could take a sample and get a feel for it, but I can't tell you exactly what it is. I can't look at every single dolphin. Is anybody not with me? Okay, maybe, okay. So normally in statistics, we take a sample to investigate some unknown group, some unknown population. So we normally do not know what this is. We normally don't know what that is. Now, to be really honest, in section 8.2, we're going to learn what to do if I also don't know what that is. So if some of you guys are really thinking about this, it might seem strange that there are situations where we don't know this, but we do know that. And that's what section 8.1 is all about. So let me give you a situation where that actually makes sense. Let's say that the standard deviation of, let's see, do I want to do that? Okay, let's say that the standard deviation of the ages of dolphins is known to be, what you got, Jeff? 3 years. Why not? You with me? So the standard deviation for all dolphins is known to be 3 years. We go to a little island somewhere. Little island with some water around it. No. All right, Jeff, calm down. I get a little loopy with this. Right, we go to some little island and we take a sample of dolphins from that island. Now, are those dolphins? Dolphins. Yes. Therefore, they are a part of all dolphins, and we know the standard deviation of all dolphins is 3 years. These dolphins, though, we're curious if, because the people on the island say, man, these dolphins live a long time. They're really old. And we're like, all right, let's check that out. Let's see what's going on. So if I take a sample of dolphins, let's say I take a sample of, what do you got, Jeff? 36 dolphins. Right? So I'm trying to get a feel for, well, okay, I'm going to keep going. So the best we can do in statistics is take a sample to estimate what the population is. What we have not done yet in this class is to go that next step, to make that inference, to say something about the whole population based on what we found in the sample. So let's see, if we take our sample of 36 dolphins and we find a sample mean age of what, Jeff? 15 years. I really should have researched dolphin ages, but I didn't. Too bad. So let's just say it's this. Is everybody with me so far? This is a little weird. I'm trying to bring concepts in at the same time, but the basic setup, dolphins are on an island. We're curious about these dolphins. We kind of want to check the people's claim out that they're really old. So we're going to take a sample of dolphins and see how old they are. Now, don't come at me with how do you tell how old a dolphin is. Let's just, we got the ability. We can do it, right? All right. Now, we just, ID them. So what do I have to do with this right now before I do any more work related to my sample of dolphins? What do I have to do with this? Anybody? So I took a sample of 36 dolphins. I know the standard deviation of all dolphins is 3. Find the new standard deviation. Thank you. Right? So sigma, the new standard deviation will be sigma over the square root of n. Right? It'll be 3 divided by the square root of 36, which is 0.5. All right, now here's the neat thing. You ready? If I go, so here's my X bar. In fact, can you guys take a minute? So everybody got their Z-score charts. I think I put one up on Canvas, a copy of the Z-score chart in case you need another one. Can everybody take a minute and figure out for me? Oh shit, let's see, can anyone let me know the formula? I can't read the second part. Second part. What's the second part? Which part, Ariana? Here, 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 here. This one? Right, so that's the same old formula we've been using from chapter 7. The old standard deviation divided by the square root of n. That piece? Oh, z plus standard, oh, you're answering your question. Sorry, Laurel. X equals mu. Oh. Yeah. So Laurel's answering your question. I got you. Z sigma. Yeah. That's the same formula we've had for a while. All right. You're welcome. You guys, I've been talking for too damn long already. You guys help me out. What are the z-scores? What are these z-scores that would capture 90% of the data? We've actually done a problem like this. I think we might have done exactly this. I'm not sure, Alex. No, Alex. 0.5 is the standard deviation. It has nothing to do with, it's not a z-score, right? Okay. This is the standard deviation becomes 0.5. This, let me ask you a few questions about this. And don't worry, I want to let you know, there's a lot of idea around this. So I'm doing exactly what I always do. I'm driving you insane with why we do what we do. Trying to explain the concept. And there's a lot of it that I got to get at you. And then I can make it a very formulaic recipe-ish thing. But I want you to understand what goes into that recipe. How in the world do you do this shit? Number one is, how do I know that I'm working with normally distributed means? How do I know I'm working with normally distributed means? Yes, n is 36 greater than 30, check. Sweet, so we're better than the book. Therefore, what I'm really asking is, what are these z-scores that capture 90%? So remember how to do that. I think we've done exactly that kind of thing before. What's the only area that the chart understands? The only area the chart understands is the area below a z-score. Right? Hey, there we go. Somebody's got it. So what area is here? What's this area right there? That would be, there's 10% outside, so there's 5% on that side. So yeah, if you do like Emily did, you look up 0.05, you're going to see something that maybe some of you guys remember. It's the asterisk thing, negative 1645 to 1645. Okay. All right, so that piece right there should feel familiar. We've done that piece before. What does that have to do with the Dolphins? Oh yeah, I know. So what I'm going to do is this. This is kind of nifty. So let's keep track of that. So if I want 90%, that means Z is going to be plus or minus 1.645. Is that cool? I'm going to put that over there. Let me kind of take some of this stuff away. Let me do this. Let me put this up here. All right, trying to get used to how to make this work best. All right. So watch this. This is kind of cool. And again, just to remind you guys, just try to take in as much as you can right now. I am going to make it very linear, very formulaic. There's just a lot of idea to throw at you. If I take, now, do you guys agree with me that around this island, there is an average age of all the dolphins? There is, right? Whatever it is, I don't know what it is, but there is one. There is definitely an average age of all of them there dolphins around that there island, right? Okay, I like it. If I we took a sample of 36. I would put money on that sample mean being different from this. If we picked our sample well, randomly, it should be close to this. Yes? So now watch this. This is such a cool idea. I know I'm normally the only one that thinks that, but let me see. We take a sample of, what did I do? 36 dolphins. We find a sample mean somewhere. If I go up and down 1.645 standard deviations from that, how many sample means, what percentage of all possible sample means did we just get in there? Let me ask that again. Some of you guys are like, did he just ask us a question we're supposed to answer? Yes. If I start at my sample mean and I go up and down 1.645 standard deviations, what percentage of all sample means should I get? No. Good try, Ray. Did I say 1? No, I don't think I said 1. If I go up and down 1.645 standard deviations. Yes. Where'd that come from? It came from having 90% inside, right? So now, if I do that, I'll catch 90% of all the possible sample means. Now stay with me, please. And some of you guys are like, dude, I'm not listening to you anymore. I'm eating breakfast. All right. So watch this. I kind of like this idea. I personally hate eating fish, not because I want them to live, because I don't like the taste. If I like the taste, I'd eat the hell out of them. Let them all die. But I don't like fish. But I love this example. If I threw a fishing net into a pond and I caught 90% of all the fish that were in that pond, how certain am I that I caught a certain fish? How confident am I that I caught? You're not 100% confident, Alex, because I only caught 90% of the fish. Yeah. I mean, doesn't that make physical sense? So now watch. Let me say that again. If I threw a net into a pond and I caught 90% of the fish with that net, then I am 90% certain, 90% confident that I caught a certain fish, right? This one fish has been like, I'm going to get you. There's a 10% chance I didn't, right? I missed it. So now watch this. If I take my sample mean and I go 1.645 steps in either direction, I will be 90% confident that the interval I make catches the real mean. That's one of the fish. Let me say that again. If I take my sample mean and I go up and down 1.645 steps, standard deviations, I will be 90% confident that the real mean is in there. So let's put some numbers on this. Oh, where's my, there you are. Come here, my very expensive eraser. All right. So let's see what this looks like. If I start at the mean and I go up and down so many standard deviations. Now, do you remember how at the beginning I said we were going to use this idea? Do you see what's happened? I used to teach it starting this way, but I think I like this a little bit better. Do you see how what color is this? Do you see how the mean, we don't know what the hell it is, so we use the sample mean? That's the best thing we know. We don't know what the real mean is, so we use our best guess, the sample mean. Then I go, z-score is right there. The standard deviation, of course, became this because I took a sample. It's the same formula. Why is it plus and minus? Because I want to go up and down to capture something around there. Okay, maybe. So let's see what these numbers come out to be. Now this is the formula. This is the recipe. If you can get all this shit, you plug it all in, you're done, right? Almost done. There's a piece of this you're going to love. And oh, that should make you very scared. So I got 15, give or take. I love to say it that way, right? Because what's 15? Is 15 the right answer? I don't know. It's my best guess. So 15, give or take 1.645 of these, right? In fact, let me just put it all back in there. Where'd it go? 3 divided by square root of 36. I like it. I haven't had this happen in a while, but I have had in the past people ask me where the plus minus button was in the calculator. Don't do that. So it's 15 minus this and 15 plus this. So what I would do if I were you, even if I were me, and I am me, I would do this first. I'm just going to do it all the way out. We already know what the answer is, but just to show you, I would calculate that piece. Are you going to show up? There it is. I would calculate that piece first. I would calculate this piece first. Guess what we call that piece? We call that piece the error. Error. Why does that make sense? Because it's the give or take. It's 15. Give or take some error. We're off by something, right? So 15 plus or minus, what do I get when I do that? 0.8225, is that what you guys got? Anybody doing that with me? Anybody still with me? I see a few people. Okay. So then you get, if I do minus this, what was that? I get 14.1775, I think. And if I add it, I get 15.8225. All right, let me stop there for a minute. All right. Don't worry, we'll do another problem from the beginning because this problem was a lot longer than it will be in the wild because I had to explain the whole idea behind it. But here's what we're doing. What this tries to do is it tries to improve on this guess. All right, you said it's 15. How sure are you about that? So if somebody said to you, oh, that guy over there, I think he's somewhere between 20 and 80 years old. Yeah. Is that impressive? Is that good? That's shit, right? It's like, thanks for opening your mouth. But if somebody said, that guy over there, I think he's somewhere between 25 and 28. It's like, okay, you could be wrong, but at least you're confident about what you're saying. I mean, at least you're like, oh, you got your error down. Your interval is really small. All right, maybe. So this interval actually seems really pretty good to me. I think here's what I can say. Here's the part that you're going to love. This is the actual nuts and bolts work. And then you're not done until you write the conclusion. Oh, yeah. So here's what the conclusion will look like. Let me take all this other stuff away. Oh, my God. I got to improve this setup, but can you guys see green? Is that all right? Yeah. We are, where'd it go? I took it away. We are 90% confident, right? We are 90% confident that the true mean age of these dolphins, oh gosh, Jeff, take that away. Here I am about to make this huge point, and I've got this the wrong way around. Okay, here we go. Obviously, this actually is good that just happened. The way you answer it is very important. It sounds semantic, but it's the idea. We are 90% confident that our interval, let's say 14.2 years, so 15.8 years, contains the true mean age blah, 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 of the Dolphins. All right. You can't read that. I know. So let me say it again. We are 90% confident that our interval, 14.2 years to 15.8 years, contains the true mean age of all dolphins around that island. So now watch this. We'll do another problem in a minute. What time we got? What time we got? We're going till 10. That's right. Okay. What was I about to do? Shit. Oh, now watch this. Watch this. If another group of people, in fact, let me do this real quick. Can everybody listen to me right now? Just hit the yes button. Awesome. Somebody took it away. I like that. Oh, and Chris is like, I don't know where the yes button is, dude. So if you don't know where the yes button is, hit participants at the bottom of the screen, and you should see your names, and then you can hit the yes button. All right, let me see who's not paying attention now. Oh, where's Angel? And let me see, Kimberly. All right, most of you guys are paying attention. Good. All right, sorry. I just wanted to do that just for a sanity check because I'm like, I might be just talking to Malachi right now. He's the only one I could actually see. So let's see. Where was that? Okay, so if another group came along and they picked another group of dolphins, they're trying to do the same thing we are. And we're like, hey, we got this covered. Like, no, we're going to beat you. We're going to write an article. No, you're not. All right. They make another interval from what they find. It's not going to be the same as ours. It depends on how confident they wanted to be. It depends on how big their sample is. It depends on what they actually see. So again, there's a real mean sitting somewhere. We took a sample. They can take a sample, right? And our samples are going to be different, aren't they? Their sample means are going to be different. But if we each make an interval around our sample means, like we just did, some of them might catch the real mean and some of them might not, just because the sample mean that we found is too far away. What percentage of all the confidence intervals that groups can come and make will contain the real mean? That's a good question. And that is the question. If I had a bunch of groups come and they all made their own, they all did all this work, they picked a different amount of dolphins, they figured out the sample mean, they did blah, 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 and they make this, and let's say that we're all being 90% confident, which basically gives it away. Then of course, 90% of the intervals made will contain the real mean. 10% of the time, a group is going to make an interval that does not catch the real mean. That is why we say, I'm 90% confident that my interval catches the real mean. You have to say it in that way. If you turn that around, you will lose points, because that's the idea of this. All right, anybody? I'm going to do one more example. Does anybody have a question before I do that? Oh, okay. I got to tell you real quick, I went to Sprouts the other day and stood in line waiting for our group to have a chance to go in the store. And I got like a little tickle, like a you know how you swallow sometimes and then you have to cough. And I was thinking, oh, I don't want to cough. They're going to throw me out. So anyway, that was neat. Okay, I don't see anybody with questions. I was just trying to waste time to give everybody a chance. So let's do another problem. Let's try another one out. Thanks, Myra. I thought it was funny. Let me see. I'm going to take all this away, right? Okay, I don't see anybody objecting. All right. By the way, I do have a handout for this. If there was more time, I would make you guys start working on it now. I'm probably going to put it up on Canvas and then go over it on Tuesday. We'll see what I decide to do. Let me see. So let's try another problem out. Let's say that we take, oh my God, a sample of 47 instructors and find a mean amount of time in Zoom meetings of per week of what, Jeff? What sounds about right? 30 hours. It's insane. It's insane. Everything's freaking Zoom. Shit. Find a mean amount of time in Zoom meeting of 30 hours. So on average, our 47 instructors average 30 hours in Zoom, right? It is known that the standard deviation of times in Zoom is 6.87, just to make a more interesting number. Become a point. Become a 6. Okay. All right, let me stop for a minute. I'm sorry. Too much glare. Where's that glare coming from? Ah, shit. It's either enough light to see or glare. It's like I can't make it. Let me see what I can do. that better? Oh, okay. All right, good. Meetings, okay. Yeah, sorry. So I'll read it again. We take a sample of 47 instructors and find a mean amount of time in Zoom meetings. Yeah, meetings is bad. Oh, well. Of 30 hours. I could have grammatically said that better, but it's pretty much always true. It is known that sigma, the population standard deviation of meeting time, amount of time in meetings, is 6.87 hours. Is everybody good with just that? Okay. So we want to create, we want to make a 95% confidence interval for the true mean time spent. Oh my God, so the last few words, just too bad. We want to make a 95% confidence interval for the true mean Zoom time, right? This true mean amount of time spent in Zoom. I wish I would have bought Zoom stock about, 2 months ago. Although now they got have you guys heard of Zoom bombing? One of my colleagues had somebody put a bunch of porn up on the screen as they were doing their lecture. That was exciting. So we learned all the settings to try to make that not happen. It definitely wouldn't be a percentage. It's hours. It's hours. So a mean of 30 hours and a standard deviation of 6.87 hours. They have to have the same units because they both describe the same thing, right? Mean and standard deviation have the same units always. Okay. So let's try this out. Has everybody got that? I have taken up like all my room, so I'm going to have to erase this. Let me put up here. Let me summarize the most important stuff. N equals 47. X bar equals where'd it go? 30. And sigma is 6.87. Right? Okay, I'm going to erase this. Okay, nobody's yelling. Let me see. What do I keep doing with that? Dadgummit. High tech. Everything's high tech. Oh, and 95%. Let me write that down. We want a 95% confidence interval. CI, confidence interval. Okay, so let me erase this stuff here. Nobody's yelling at me still, so I'm going to assume that's okay to do. Oh my gosh. All right. Oh my goodness. Oh my goodness. All right. So now watch this. I know the formula is going to be our best guess, give or take this many steps. I like that the formula, can you guys see the formula? I got no marker that works well anymore. Damn it. Damn it, Jim, I'm an instructor, not a marker maker. All right. Too bad, Jeff. It's just too bad, Jeff. I'll get over it. Okay, nobody's saying they can't see that. So it's the same as this one. They really are the same formula. It's just I don't know mu, so I have to use X bar. The Z is right there. It's the standard deviation, of course, changes. And then it's plus and minus because I actually want to find two values. I want to go up and down. But they're the exact same formula. Is it possible to take the formula in chat? Sure. Let me see. Let me not put it just to one person. Let's see. Oh, well, it's just going to be neat. X bar plus minus Z times standard deviation divided by square root of n. You're going to love that. Here's the nice thing. Here, let me see if I could do this. Do I have it? Where'd it go? Give me 1 second as old man figures out. Here we go. Bam! Look at that shit. There's the formula right there. right there. This is the handout that I'm going to put up on Canvas. So there is the nice formula. Okay. Notice this is about dolphins also. I have no idea why I'm suddenly fascinated by dolphins. Okay, Alex, I'm not sure how to take that wow, but I'm going to take it as a nice way. Let me think. What was I just doing? Oh, all right. What's the only thing in here that we don't currently know, that I wasn't just given? It's kind of funny. Exactly. It's kind of funny. And this is not a failing of mine. You could think otherwise. I know it takes me forever to kind of talk about an idea. This has happened a couple times. It takes me forever to talk about an idea, and then the actual work is minimal. I'm given X bar. I have to be given X bar. I'm given sigma. I have to be given sigma. I'm given n. I have to be given n. And then the only thing I don't know is z. How the hell am I going to figure out what z is? Could be the same way we did before. In fact, it will be the same way we did a minute ago. How confident do we want to be? 95%. Is this a normal distribution I'm working with? Definitely, because n is greater than 30. Oh, where you at? There you are. So how do I figure out the z-score? Well, 95% confidence. Is that all right? Yeah. I get the glare. You don't get the glare. Okay. 95% confidence would have 95% in there. So how much is down here? How much is down in that poor little tail right there? Got a little time to tell you, not 2.25. Don't go too far. Yeah, 2.5. Right, there's 5% outside, so there's 2.5. Which side? 2.5 on this side. 0.025. Can you guys look that up for me in the chart? I'm going to make you do it that way, and then I'll show you a shortcut. It's just like a teacher to do that shit. If you look up 0.025 in the body of the chart, and of course, what kind of z-score is this? Negative. So if you look up 0.02, here's the O2s, I think. Let me see if I can see it. Yeah, there's the O2s. 0.025, I get exactly something. I can't show it to you and see it at the same time. I'm sorry. There's 0.025, right? Am I pointing at 0.025? I can't see. Yes, I am. All right. So if you look out 0.025, I get 1.96. Look at me catch up. Okay. So that's negative 1.96. Do you have to do any work to figure out what that one is? What's that one going to be? Yeah. Positive 1.96. Symmetry. It's symmetric. Boogie woogie. So what this shit is all this stuff mean? So the only thing I didn't know is how far to go away from my best guess to make sure I capture enough stuff to be that confident I caught the right thing. I love the analogy of the fishing net, because if I want to be more sure that I catch a certain fish, I'm going to throw out a bigger freaking net. So the more confident I want to be, the further out I've got to go, making my net bigger. Because I'm just going to catch more shit then. So of course I'm going to be a little more confident that I caught a certain thing. What's the only way to be 100% confident is to have an infinite-sized fishing net. So it sounds a lot like real life. Can you ever be 100% confident in real life? No, you can't. Nope. Hell, we could all be in a simulation. So don't come at me with something you think you could be confident about, because you cannot be. That's a little bit morbid. I'm sorry. So now if I plug stuff in, there's my best guess for what the average is. Give or take 1.96 standard deviations. 6.87. Oh my God. Come on. See if you're working. You're working a little bit. Divided by the square root of 47. Oh my gosh. Okay. And again, it's my suggestion to figure this piece out first. So it'll be 30, give or take. Arg. Is anything going to work? Let me see. Can you work? No. How about green? Can you work green? A little bit. Okay. So anybody do this yet? Can you guys figure out what that is? It's just about time. Oh, that's so weird. Oh, that makes sense. That is really, I didn't force that. It's not 1. What you get is kind of weird. Yeah, you get basically 1.96 again. Because square root of 47 is almost exactly this. That is really trippy. Very trippy. Yeah, not 1.9641, but you can round it. So if I do 30 minus this, I'll get 28.03. So basically 04 roughly. And then if I add it, I get 31.9641, blah, blah, blah. You can just make it 96. All right. So the final step is to say, I'm not going to write this down. I'm just going to say, we are 95% confident that the interval, I didn't give this units. Shit, I always want units. I didn't give this units. This is one situation where you don't have to give units. We are 95% confident that the interval 28.4 to 31.96 contains the true mean average of this data. Right? So that is how you take sample information and expand it to be an inference about the population. Now, real quick, anybody paying any attention to this thing? What is it? An election coming up? Anybody? Primaries, election, politics, or you like, holy shit, I couldn't handle it even before the pandemic. Whenever you see somebody saying, it looks like 44% are going to vote for this person, they, at the bottom of the screen, there's always a plus or minus 3, plus or minus 4%. And if you never noticed that, go look for it. That is exactly this. That's the error. Because where do they get their information from? A sample. Has anyone ever called you up and asked you who you're going to vote for? Nobody's ever done that for me. So how do they get that information from a random sample of people? And there's 360 million people or whatever. So it's a very low chance you would get picked. That's enough. All right, that's enough. So let me see. You guys might still need that. So right now, the minute I kill this meeting, I'm going to go make the quiz active. So if you have time right now, you might as well go do it and submit it through Canvas and be done with it. What was I going to say otherwise? I forget. And then I'm going to post this lecture, of course. I'm going to try to remember to post the handout so we can look at that on Monday. I'm sorry, Tuesday. I think that's about it. Any questions before I head out? Anybody want to hang out for a bit? Well, the quiz have a time limit. It's going to be due by 11:59 tonight. So just to remind you guys, I can't remember how much I've talked about. So everybody knows no more tests, right? Except for the final exam. If you haven't gotten the updated syllabus, check your email. So I changed the percentages around a little bit. There's no more. The quizzes, I'm going to trust you because I'm crazy. You should treat a quiz just like you would treat it in the classroom, meaning hopefully you're not cheating. So you can't use other people. You can't use the internets. No, it's due by midnight. It's due by 11:59 tonight, period. I don't care when you open the damn thing. But now I'm gone further, Evan. I'm sorry. I'm not answering your question anymore. I'm just talking about everything else. So yeah, there's no time limit. Download it. Do it. It's due by 11:59 tonight. What was I saying? Shit. Oh, the final exam will be on Zoom. Everybody's going to need to have a video playing capability so I can sit and watch you take the final. That's the only way that I can keep the integrity of the course, because most of you guys are not going to do evil things on the quiz. You're not going to try to cheat. You're not going to try to get outside information. Some of you will. The final, you're not going to be able to. So why do that? Take it like you would a normal quiz, so you are certain you are ready for the final. You want us to scan it? Yes, please, yes. So you don't have to print the quiz out. You can if you want to, of course, and do your work on the quiz, scan it, and send it. Hopefully everybody has an app to scan something with the PDF. If you don't, when you go to Canvas, there is a Pages link underneath where it says assignments and all that kind of stuff. And there's a page that says photo to PDF. There's a bunch of apps for iPhone, for Android, for whatever the hell you got. There's PDF scanning apps. Okay. Malachi, your audio is cutting out. Oh, 95% means there's 2.5% on either side. So if you look up 2.025, you'll get negative 196. And so this one would be positive 1.96. Okay. Cam scanner, I love it. I love it. That'll work. I use something called Tiny Scan. It's for Android, and it works fine. So just get something. If you absolutely can't find something that'll save it as a PDF, try to send me an image, but there's a lot of those that people are sending me that I can't open. There's just some weird format. PDF is the easiest transferable file format. Doc scanner. Oh yeah, sure. There's a ton of them, dudes, people. So I got a list of some up on Canvas, some apps. I don't care what app you use. I don't care. As long as I can read what it is you're sending me, I'm a happy boy. Anything else? Any other questions about anything? No. Okay. All right. So that's it. You guys can start logging out if you want to. I want to watch, because when you log out, it's like watching bubbles pop. Pop, 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 pop. If anybody else has any other questions, you can hang out and ask away. I got to go to Canvas and make this active real quick, and then I'll see if anybody's left. I hear people leaving. I don't hear anybody asking questions. All right, they're both active now. So you should be able to find the quiz up on Canvas. Who's left? Anybody that's left have a question? Let me see. Did I miss something? Let me go back through chat. Thank you, thank you, thank you, thank you, thank you. Okay. You don't have to thank me. It's my job. So we print out the quiz and then scan the quiz, or just like we write our answer for the problems on a sheet of paper, scan that. Yes. Either way, whatever works. I had somebody not turn it in and they sent me an email saying, I can't print. How do I do it? Well, just do the work and scan it and send it to me. I know what the problems are. I don't need a copy of the problems. I made the problems. 5, so somebody's got a question about number 10 from 5-1. Let me see. Oh, all right. So all the shit they talk about on number 10, Victor, the function is restricted to 0 to 5, right? The only values that x can take are 0 to 5. So what's the probability x is less than 0? No? Yes? Is that right? Are you still here? Yes, you are. If the only values x can take, so number 10 says the function is restricted to 0 less than or equal to x less than or equal to 5. So x is between 0 and 5. What's the probability x is less than 0 then? Okay, yeah, that's it. Yeah, you got it. It's 0. It can't happen because x can only take on values between 0 and 5. I like it. All right, guys. There's a lot of people left. Are these the people that aren't really here right now? Is anybody up here? Let me see. Are you the people that turned on the lecture and then went somewhere else? Or no? What are you guys doing? Victor, I know you're here. You were just asking me questions. Lanja, Brian, Kalisha, Myra, Sarah. Myra, I think you just said something earlier. You guys really here right now? You don't have to be. There we go. Thank you. Kalisha's got a question. Number 8 for 5-1. So very similar. The answer for a continuous probability problem will be the area related to that question. So number 8 says, what's the probability x equals 7? The area of a line, x equals 7, there's no width, no area. So that probably is 0. You always have to find the area of the question in the picture, and the area of a line is 0. Is that all right, Kalisha? Okay. I'm going to assume that everybody else is not really here. There we go. Kalisha, I know you're there, but I think the rest of you. Victor, good. I know you're there. Sarah, Lanja, and Brian. Lanja, you're here. Do you have a question? Oh, Sarah's here, just listening. How about Brian? Oh, you're here. All right. Why? You guys have questions? Otherwise, I'm done. I'm done. If you don't have a question, then we're all done. Go find the quiz up on Canvas and get started on it. And let me know if you have any technical difficulties, okay? I'm going to kill the meeting. I'm going to kill it. Good to see you. I didn't see any of you guys, but can I email you? Of course, Brian. Of course you can. Go ahead. All right. Otherwise, I'm leaving. So email me, Brian, and I'm leaving. Bye.